Everyone thinks enterprise multi-agent systems are driven by massive LLM context windows. But if you look at the architecture, it actually relies on a centralized vector database. When you have a coding agent, a debugging agent, and a testing agent all working on the same code base, your context window limits become a massive bottleneck. You cannot simply pass a 50,000 token chat history back and forth between them. The latency will destroy your system and the token cost will bankrupt you. Today, we are reverse engineering the exact system design top tech companies use to let independent agents share context in real time. The first fundamental shift is moving from stateful agents to stateless agents. We completely decouple the memory. Instead of a supervisor agent holding all the context, we drop a high-speed vector database right into the center of the swarm. This is our shared architectural brain. Whenever the coding agent writes a function, it immediately embeds that code and writes it to the database asynchronously. It frees up its compute threads and goes straight back to work. Now, when the debugging agent wakes up to fix an error, it does not read the entire historical log. It performs a semantic search. It queries the vector database for the specific error signature, retrieving only the exact 3 chunks of code it needs to see. By treating context as a searchable database instead of a linear chat log, we bypass the token limit completely. But how does the debugging agent actually know when to execute? If these independent agents constantly pull the database for updates, you will create massive compute waste and throttle your system. This is where we inject an asynchronous event bus like Redis PubSub or Apache Kafka. When the coding agent finishes writing to the vector database, it fires a tiny lightweight metadata event to a specific topic partition. The debugging agent is subscribed to this exact topic. It receives the ping, wakes up, and only then does it execute its semantic search against the vector brain. This decouples the compute trigger from the heavy memory storage. But if you run this system for hours, that vector database becomes incredibly bloated. The production secret is a background process called memory compaction. While the main swarm works, a lightweight background agent continuously scans the vector database, clustering old conversational chunks and summarizing them into dense core memories. This creates a highly elastic self-pruning architecture. By isolating your memory state into a centralized vector layer, your multi-agent swarm can run infinitely without crashing from token limits. Hit the subscribe button to master advanced high-level design patterns every single week. Now, dropping a central database into the middle of your swarm creates a massive read-write hotspot. If your underlying storage tier is not architected correctly, it will bottleneck instantly. To see exactly how to design a distributed data matrix for billion-scale traffic, click on this breakdown right here.